Okay, so we're diving into fusion energy, specifically all the talk about China leaving the US in the dust on this. Got a whole bunch of reports to dig through: CERN, Wikipedia, the IAEA, even a CNN article comparing US and China's game plans.
And what's so fascinating about this is it's not just about building some fancy reactor, right? It's about who shapes the future of energy, of the world, really.
Absolutely. But before we get ahead of ourselves, let's make sure everyone's got the basics. What is fusion at its core? We hear power of the sun, but what's actually going on down at the atomic level?
Imagine the tiniest magnets you can think of, like seriously small. Those are atomic nuclei. Fusion is basically cramming those magnets together so hard they fuse into a new, bigger one.
And I'm guessing that releases a tad more energy than your average fridge magnet.
You could say that. Millions of times more energy than splitting atoms, like in those old fission reactors. We're talking potentially powering the planet for millions of years. The IAEA reports say that. And get this, using fuel we can just extract from seawater.
Clean energy for that long. Okay, I see why people are excited. So why aren't we all driving fusion-powered flying cars yet? What's the holdup?
Remember those magnets and how we have to basically crush them together? Turns out that's a teeny bit tricky. It takes temperatures hotter than the sun's core, insane pressure. It's like creating a miniature star right here on Earth and keeping it stable enough to use.
And I'm guessing that's a bit more complicated than it
It
sounds.
makes rocket science look like child's play. That's why it's been such a long road, scientifically and engineering-wise, to get to where we are now.
A long road with some pretty high stakes by the sounds of it. And speaking of stakes, that CNN piece really hammered home how seriously China's taking this fusion race.
Yeah, and to really understand why everyone's so worried, you got to look at the tech they're building, how fast they're moving. That's where it gets interesting.
All right, so China's fusion strategy, CNN definitely seems to think they're going for the gold here, pouring money into research way more than the US, and now some US experts are getting nervous. What's driving this fusion frenzy, and should America be worried?
Well, the money is definitely attention-grabbing. No way around that.
Yeah.
CNN was talking about this new GRFT facility they've got cutting edge, right? Cost them like $570 million. That kind of cash, it attracts the best scientists, lets them build incredible stuff. Meanwhile, you've got U.S. labs struggling to even keep the lights on in their old facilities.
Sounds like they're building the Ferrari of fusion labs while we're stuck with our dad's old station wagon. But it's got to be more than just fancy equipment, right?
Oh, absolutely. The real key is the innovation, what they're doing with it. Look at energy singularity. They were in that CNN article. Startup company built a whole tokamak in 3 years. 3. That's unheard of.
3 years? Seriously. That's faster than some Silicon Valley app launches. What's the secret sauce? Did they skip some steps?
Not skipping steps, more like rewriting the rule book. They're using high-temperature superconductors in their magnets. Way more efficient than the old electromagnets.
Uh-huh. High temperature, super. Okay, you lost me a bit there.
Basically, think of it like this. Stronger magnetic fields, less energy wasted. And that's huge for containing the plasma where fusion actually happens.
Right. Got to keep that super hot stuff contained somehow. So not cutting corners, just building better. But China's not just relying on startups, are they? That East Tokamak, the one setting all the records, that's government-backed.
Yeah, the Experimental Advanced Superconducting Tokamak, or EAST. It's like China showing off what they can do. They hit temperatures 5 times hotter than the sun's core. Did you know that? World record. By a mile.
Yeah.
And they held that plasma stable, get this, for over 17 minutes. Another record.
17 minutes. I can barely boil water for that long without getting distracted.
It's a huge deal. For fusion power to work, we need to make those reactions last. EAST is proving it's possible.
Okay, so let's recap. State-of-the-art facilities, top scientists, breaking records left and right. It's starting to sound like China's got this in the bag. Does the U.S. have any chance of catching up?
Hold your horses. It's not over till it's over. The U.S. has some tricks up its sleeve, you know. They're trying some totally different approaches to fusion, stuff that could give them an edge. We'll get into all that after the break.
All right, so we've seen China flex its fusion muscles, but I'm guessing the U.S. isn't just rolling over. CNN did mention something about lasers being a potential U.S. advantage. That sounds a bit more exciting than those giant tokamak donuts.
Yeah, it's got that sci-fi appeal, doesn't it? And here's the thing. The U.S. isn't putting all its eggs in the tokamak basket. While China goes all in, the U.S. is hedging its bets, looking at laser fusion as a serious contender.
And that's where Lawrence Livermore comes in, right? They were the ones who got that net energy gain from laser fusion. That was huge.
Huge doesn't even cover it. First time ever, anywhere, that scientists got more energy out of a fusion reaction than they put in. A real game changer.
Okay, so still not quite ready to plug our toasters into laser beams, but it's a step towards that future now.
It is. It really is. Proves that laser fusion isn't just some theoretical idea, it actually works. Now, to be totally transparent here, this isn't about a working power plant tomorrow. That net gain, it doesn't include all the energy you need to power the lasers themselves, which is no small thing.
Gotcha. So a huge win, but laser fusion still has a way to go. Is that the US's ace in the hole then? Ditch tokamaks, focus on lasers.
It's not that simple. The U.S. is also a big player in ITER, that massive project in France, building a next-gen tokamak, but with a bunch of countries working together. And that brings up a really important point. This isn't just a U.S. versus China thing. It's global.
Right, a worldwide fusion team up. Why is that so crucial? Just to share the workload, or is there something more to it?
It's bigger than just resources, though pooling them definitely helps. When you collaborate like this internationally, it helps make sure no one country controls the whole game. Fusion could really shake things up globally, so making sure it's a shared resource, that's vital for everyone, really.
Yeah, it makes sense. It's not just about who gets there first, but what happens after we get there. So, with all this in mind, any chance we'll see fusion power in our lifetime? Asking for a friend.
Well, the IAEA, they're saying we could have commercially viable fusion by the 2050s. Some of those private companies, even sooner. But fusion, it's a beast, let me tell you.
Right.
Still plenty of challenges to overcome. And that's where the IAEA's work. It's so crucial.
How so?
They're not just watching from the sidelines. Safety standards, regulations, making sure all this research is done responsibly, sustainably, because it's not enough to get fusion right.
Yeah.
We got to do it right in a way that benefits everyone.
Yeah. So yeah, China's making waves, but this fusion race, it's far from over. It's a global marathon, high stakes, potentially changing the world as we know it. It'll be fascinating to see how it all plays out.
Absolutely. And as you keep an eye on all this, here's something to chew on. How's this all going to work? National ambition versus global cooperation. How's that going to shape fusion's future? And what role will we all play, right? Living in a world on the verge of this huge energy revolution. Something to think about.